Hi there and welcome to this tutorial for Motion Symphony. In this tutorial we're going to talk about optimization for motion matching. Obviously with motion matching we have a list of poses that we search through, and if we search through this big list of poses linearly, it's going to take a lot of CPU time, and therefore it's ideal that we structure our data in a way that it can be searched really fast. So we're optimizing the pose matching search. So there's a big section in the documentation on motion matching optimization, and there's quite a lot of information here and even on how it works in the two different methods that are provided. You can even create your own optimization because, like with everything in Motion Symphony, it's modular. So let's have a look at how we do this. I'll show you one that is already been done. I have this, this is part of the example project, and you can see that optimization is checked. And we have this asset here, and this is the multi-clustering optimization module. I'll show you how to create these in a bit, but basically when we pre-process this, there's going to be a second phase of pre-processing. Once we've created our big list of poses, the second phase is all about creating these optimized data structures. In the case of multi-clustering, it's multiple steps of clustering trajectories and poses into a data structure that we can search maybe just 500 poses instead of 50,000. That's going to give us a really big saving in performance. Okay, so let's have a look at this in action. I'm going to just hit play, and this is the character that is using this run locomotion data. And we can see our character is running just fine. Let's hit tilde and type in a.animnode.mosymph, and let's go to search debug, and we're going to set that to 2. Sorry, it's not going to be 2, it's going to be 1. Mosymph search debug 1. And we can see there are a lot of lines drawn on the ground. And these lines represent the poses that are being searched each time it flashes. It's a search, and it's only searching these poses. Now, it might look like a lot, but if we look at the top of the screen, we can see that it really isn't compared to the grand scheme of things. We're searching roughly 700, maximum 1,000 poses out of a total of 10,000 poses, which is roughly a 5 to 10, so only about 5 to 10% of the poses are being searched every frame. We have a low of 251 poses searched in one given frame and a maximum of 1146 in any given frame. So the idea is that we're searching only poses that are already similar, but can take us in every direction. And that's why we get this large spread of coverage in our pose search. So that is basically the multi-clustering part of the optimization. So let's go to our tutorial, and I'll go to this tutorial motion data that we created early. Let's check optimize, and in the optimization module, let's start with creating a multi-clustering optimization module. We can choose where we want to put it in our project, and I'll just put it here. I'll go tutorial multi-clustering, and we'll hit save. That will be created. Now when I pre-process, you'll notice that it's going to take a lot longer. It might seem like it's frozen, and to be honest, that was actually still quite quick. The data structures are all created, so when we now play this, it should run properly. So I'm going to change to our tutorial character, and I'll hit play, and we get a similar thing. In this case, we only have 2,205 poses, and it's still searching only between 400 to 500 poses in any given frame. You'll notice that that's only about 75 to 80% reduction in poses. However, the optimization module has a much higher impact with the more poses you have in the first place. So this is a very significant reduction, and you're going to want to do it. The only reason you wouldn't have optimization on is if you're trying to iterate very quickly and you want the pre-processing to happen very quickly. So you can also create your optimization modules directly here, either a multi-clustering or a trait bins. Just keep in mind that you can only use one optimization module with one motion data because it bakes the data structure in there. The reason it's modular is that we can have different types of optimization or to customize our own optimization. So this trait bins version is more of a base case. It only splits up the animation poses by their traits. So it's basically for each trait, combination, there's a list that can be searched. So if you're not using traits, it's not going to give you any benefit. So it is a base case and almost an example of how to create an optimization module. I'm not going to get into how to create your own custom optimization module in this tutorial. That's more of an advanced technique for people who are very familiar with C++, very familiar with UE4's environment, and can look at the source code for Motion Symphony and try and replicate one of these with their own data structure. There are many different data structures that you can use with motion matching, so I didn't want to limit it to just what I thought was the best at the time. So there we have it. That is optimization modules for Motion Symphony. I hope you've learned something. This should bring it to a production-ready level of performance for games. Thank you for watching. I will see you in the next tutorial.